Hello, and welcome to migrating a monolithic application to microservices. I'm your speaker, Soeren. I'm a software engineer in Google Cloud. Your feedback is greatly appreciated. The surveys are going to open, they said, in 20 minutes-ish, I guess. Give me 5 stars, like, and subscribe. I'm sure everyone's made that joke. Allow me to introduce myself. Can you all hear me, by the way? Great. My name is Soeren, and I work in an org at Google called Cloud Engineering Productivity. And today I'm going to tell you about 2 projects I've worked on in cloud, Louhi and GlassPane. Unfortunately, my teammate Sergio, who is the... Oh, I didn't mean to go to that slide just yet. Let me go back. Can I? Yeah. OK, my teammate Sergio is the tech lead on Louhi, this first project here. And he couldn't be here today. He gave this talk with me in San Francisco earlier this year. And I just want to give him a quick shout out because he's graciously allowed me to still use all of his examples in this presentation as examples in the talk, as you'll see. So thank you, Sergio. All right, a show of hands. Who here has heard of release orchestration before? Anyone? OK, a few people. How about CI/CD? Ah, more of you. OK, that's what I thought. All right, well, Louhi is essentially a release orchestration tool. Release orchestration, for those of you who don't know, is essentially how you can automate the process of planning and managing a software build through different stages and environments, including testing and deploying releases to your end users through continuous integration and/or deployment, which is what CI/CD stands for. Like most other tools relating to CI/CD, Louhi has this concept called a flow. A flow is composed of 3 things: triggers to begin the flow, a pipeline with multiple steps to execute, and finally, notifications that fire when the pipeline finishes. But what makes Louhi a little different from other CI/CD tools you might know is that it's primarily designed to handle hybrid applications, which are apps that may use different tech stacks, different tools, or even completely different infrastructures. Now, GlassPane, on the other hand, is a metrics tool. I'm sure you're all familiar with the concept of metrics. It's essentially an internal metrics platform at Google that allows directors and managers to understand the health and relative performance of their projects and their teams. So today, I want to tell you a story about how we took both Louhi and GlassPane and converted them from monolithic apps and split them up into microservices. But first, what is a monolithic app? Well, traditionally, this is the way most engineers used to think about applications being shipped as large, unchanging chunks of code that simply met the initial requirements set out by product teams and executives, no more and no less. All the functionality and business logic is compiled together in a single binary with a single data layer. This has some advantages and some disadvantages. Of course, we decided to build Louhi and GlassPane as monolithic apps in the first place. Why did we do this? Well, monolithic apps allow you to experiment quickly. They allow you to focus on the business logic of your application without having to worry about all the complex interactions that can be involved when you start to introduce new binaries. It prevented initial over-design of our services to begin with. We just wanted to get something hacky, quick, up and running. We were also a pretty small team, so having one monolithic app allowed us to pretty easily manage the changes that we needed to make. Also, having one binary means that we only need to do things like debugging, security, and operations once. It was good while it lasted, don't get me wrong, but as our project and team size grew, we started to face some new challenges. We started to feel like we had gotten ourselves into a mess. We started having more product requirements as the project gained popularity within Google. We began onboarding new team members, and that became difficult because there was too much cognitive load every time we brought someone onto the team. They had to learn the whole architecture of the entire application. We had to start delaying deployments in order to sync features across the different sub-teams that we started having. There was also no way to independently scale the application, the different pieces of the application, rather, that needed, for example, one part might need more performance than another one, but there was no way to do that. It also became pretty messy to debug because we weren't very good about keeping everything separate in the binary, which is possible, but we weren't very good at it. So everything just got really mangled together. So we started to feel like we had just built this cage around ourselves that we were desperate to escape. And this is where microservices came in. But first, what is a microservice? And where do they come from? Okay, a little history lesson before we get into the nitty-gritty details. Before microservices became popular, service-oriented architecture was introduced in the late 90s. The separation of business logic into different modules was a big improvement over monolithic apps, but it didn't go quite far enough in terms of decoupling services from each other. If their application was like a loaf of bread, it was kind of like they figured out how to slice the bread, but then they just still wrapped it all in one big wrapper anyway. Finally, and not the best analogy, but you get it, right? Okay. Finally, the industry figured out how to completely decouple the services into microservices, even for large-scale enterprise-grade applications with millions of users. These tiny services introduced a lot of neat benefits. Here are some of those benefits. Microservices, turns out, are pretty simple to understand. These small services have a pretty simple onboarding process for new team members that may want to join your team. It also allows you to work on different tech stacks. One service might be in Python, another might be in Java, etc. They also guarantee something called isolated responsibility, which I'll get into later. It's a part of a broader concept called domain-driven design that tends to work really nicely with microservices. You can also deploy them completely independently. They're scalable and distributable. You can reuse business logic across your application without having to rewrite it or have complex interdependencies. And microservices are really fault tolerant. I'll show you some patterns later about how you can handle situations when services go down. Much better than you can with a monolithic app. All right, so if, like us, these benefits sound nice, and you're thinking, okay, maybe I do want to migrate my monolithic app into microservices, how do you actually go about doing that? Specifically, when we decided to migrate GlassPane and Louhi into microservices, we asked ourselves two questions. One was, how big should the services even be? And two, how do I go about splitting them up once I've decided on the size and number of microservices? Well, the micro part of microservices, it turns out, is more of a label than a description, to be honest. The size of a microservice can vary, which is the whole idea behind service granularity. Unfortunately, there's no one-size-fits-all approach. It's going to depend on your tech stack and your infrastructure. Ask yourself, on my tech stack, how much overhead is associated with setting up a new service? A good rule of thumb is if it costs more to set up and run your service than it does to implement it, that's a sign the service is too small. As I previously mentioned, a good approach to use is something called domain-driven design. Domain-driven design essentially means thinking about each piece of your app as a separate domain. Here, it's important to have bounded contexts around your domains and to follow the single responsibility principle, where each domain is only responsible for a single thing. If you're familiar with object-oriented design, this is kind of like each microservice handling one strong entity per service. along with its related business logic and data layers. But beware of an anti-pattern called nanoservices. This is essentially when your services are too small, and in just a moment, I'm going to show you an example of how we learned this the hard way in GlassPane so that you don't make the same mistake. But first, how did we decide on the number of microservices? Turns out GlassPane's magic number was 7-ish. By our estimation, the original monolith had approximately 7 different domains, so we decided to split it up in 7 ways. The core service was our new microservice that handled user requests and talked to the other 6 services, each handling their respective domain. Sounds good, right? Unfortunately, we took things a little too far when we decided to create a separate metric collider service for every single metric in GlassPane. This is a classic example of something called nanoservices, or services that are too small. If GlassPane was going to support hundreds of metrics, we were going to need hundreds of microservices. But not only would we need to build, deploy, release hundreds of microservices to both prod and QA, we'd also need to set up the APIs and other GCP services to execute the business logic. These are, oh, I was supposed to click through those. That's the business logic happening. This was not feasible for our team size and our tech stack, so we decided instead to go with this sort of serverless approach. We'd have a single microservice responsible for all the metrics. This meant that we only needed to build, deploy, and test and release to a few different staging environments, prod and QA and maybe dev. But by using Google Cloud Functions to collect metrics instead, we ensured this service still obeyed the single responsibility principle, but without all the maintenance and setup that was required for a new GAE instance for every microservice, essentially. OK, we talked about deciding on the size and number of your microservices, but how do you actually go about splitting up the application? If you have a monolithic app, one useful pattern for this is the Strangler Pattern. And it gets its name from the strangler vines of the fig tree, which essentially start at the top of the tree, up in the leaves, and they slowly creep down the tree until they've rooted themselves in the soil, and the tree dies. Think about your monolithic app like that. Just kill it at the end. If there's one thing to remember about strangler vines, though, it's that they start at the top because the smaller branches are the easiest to consume. Good thing to remember later. OK, so let's walk through an example. The big thing you want to see, how do I split up my monolithic app? To start with, we have our monolithic app. It's a single binary composed of 3 services and 1 database that handles all the user's requests. So the first step in the Strangler pattern is to set up something called a proxy, so that now, when the user sends a request, we can begin redirecting traffic to where? Any guesses? You can just shout them out. Sorry? Back, that's actually right. We're first of all going to just redirect traffic back to the monolith. Right now, it's not even going to do anything. It's just an extra layer we've added that eventually we're going to use to redirect traffic to the microservices. But right now, we don't have anywhere to redirect to yet. OK, remember what I said about strangler vines? Where do they start? Where it's easy. Yes, OK. At the top, because it's easy. So here, the least complicated service happens to be the inventory service, so that's where we're going to start. So first, we create a separate binary with a separate database to handle inventory, where we can start re-implementing the necessary logic for the inventory part of our application. But before we begin implementing, we should first set up a link between the proxy and this new binary so we can begin to redirect the traffic once the new service is implemented. Then we can just remove that part of the monolithic app once the new service has replicated all the old logic from the inventory part of the monolithic application. OK, so the next easiest service happens to be the shipping service. So like the Strangler vines, we'll take that one next, and we create a new binary, hook it up with the proxy, and begin re-implementing the shipping logic from our monolithic app in this new binary. Perhaps you copy over some code, perhaps there's some new code, perhaps it talks to some new services, you set up a different database, etc. Then we remove the shipping part of our monolithic app and repeat for the final service, the accounting service. Drop a new binary in, set it up with the proxy, implement the logic, remove from our monolithic app, and now the tree has been entirely consumed, and voila, you're in microservices. Thank you. Just kidding, that's not the end. One thing to beware of is that there's an anti-pattern called data-driven migration. What is that? Well, you may be tempted to begin with the data side of things when you start to migrate your monolithic app over, rather than the implementation details and the business logic. This is actually the opposite of what you want to do. I won't have time to go into details about data-driven migration, but you should look up Martin Fowler's article about this. If you're curious why, read that article. So when we split up Louhi, for example, this process of using the Strangler pattern ended up being pretty straightforward, because in our original monolithic app, we only had a few modules that all already were sort of separated out into their respective domains. So each module just essentially became a new microservice, for the most part. There were a few exceptions, which I'll talk about. One of those exceptions was the pipeline module. So in the original Python implementation of Louhi, the pipeline module was responsible for storing the pipeline configuration, managing the state of a given pipeline execution, managing the stage types catalog, and it contained all the implementation details that needed to run those actual stages. It was sort of like a Frankenstein module. So when we were moving to this architecture, we decided to split it up. So instead, when we implemented microservices, we had a separate pipeline service that managed the state and configuration of the pipeline, a stage type service to contain the catalog of available stage types, and finally, the GCB executor, which takes the stages and runs them. All right, now that you know how to split up your app, where should you start? Well, a good place to start is with source code and documentation. Raise your hand if you know what a design doc is. OK. Raise your hand if you've ever written a design doc. Fewer of you. I thought so, yeah. Nobody ever writes design docs, but they're important. You should write them. You can use design docs specifically to create a strategy about how you're going to migrate. What we did with Louhi and GlassPane was we essentially created one doc for the final architecture design, and then multiple docs, one for each microservice, to talk about the entities they were responsible for, the related business logic and data layers, and so forth. Also, one thing to note is you can establish clear boundaries between them about the contracts between your services. It's really nice. One other thing to consider is, do you want to split up your repository into maybe a repository per microservice? With Louhi and GlassPane, we decided to do this, namely because they allow us to establish really clear dependency relationship between the microservices. It's pretty obvious in the dependencies when you're depending on another service if they're in completely separate repositories. It also allows you to pretty simply deploy them separately because they're separate. Finally, set team responsibilities. If you're a small team, maybe you have one person who's responsible for several microservices. And if you're a large team, maybe you have a whole sub-team dedicated to a single microservice. Just depends. But it's important to set up those responsibilities so that there's no orphan microservices lost along the way. Now, one thing you might be wondering is, how do I share code between my services with all of them existing in separate repositories potentially and being deployed as separate binaries? Well, the way we decided to handle this in GlassPane was by setting up a common repository. This is essentially a repository that all the services can depend on for shared code without having to depend on each other or without having to copy code from service to service. It's really, you can feel free to use this same strategy. So, you've designed your services, you've written design docs, and you made a plan for your source code. So how can you decide on a tech stack? Microservices can be implemented in many different ways. You could create separate app engine instances, or use a customized compute engine, or even use containers on Kubernetes. For data-heavy apps, Firebase is a good choice too. You can go serverless even with something like Google Cloud Functions, or if you're not ready to move everything to cloud just yet, you can even use tools like Knative to essentially run microservices on-prem using your own existing infrastructure. In Louhi, we decided to use GKE. GKE allowed us to deploy a wide variety of applications using containers. Essentially, if you can containerize it, GKE can run it. It also gives you nice things like SelfHealing Services and the ability to auto-scale them as needed. And we get declarative configuration out of the box with also easy network setup and automatic upgrades to the latest Kubernetes versions. And GKE also integrates pretty easily with other GCP services. For the backend framework, we chose Java and Spring, in part because our new team, once we'd onboarded new members, was more familiar with Java. Spring is a pretty mature framework used throughout the industry. It's open source, it was built to run in the cloud, and it's as flexible as you want it to be. You can configure things yourself or let Spring configure things for you. And there's tons of documentation online to play around with, so it's easy to get started. Specifically, in Louhi, we took advantage of these two technologies designed to easily integrate Spring with GKE. The Spring Cloud GCP project enabled us to integrate with other APIs and services on GCP out of the box, and Spring Cloud Kubernetes allowed us to easily consume native Kubernetes services. Both Louhi and GlassPane also use this front-end framework called Polymer for our front-end UI. And you might be wondering, why am I talking about a front-end framework in a talk about microservices? Well, Polymer takes advantage of something called web components, where each piece of the UI is essentially a separate component with isolated responsibility. So we can think about our front end in the same way as our back end. Take the navigation drawer in Louhi, for example. As you can see, each element is actually composed of its own small, independent, reusable web components, just like the services that we've been talking about. I encourage you to check out the Polymer project and the Lit project if this sounds interesting. Anyway, pardon my digression. Where were we? Well, I mentioned some of the benefits of microservices, showed you how to migrate your app using the Strangler Pattern, and I told you how to get started with design docs, source control, and tips for choosing a tech stack. So, are we done? Not quite. I imagine you might still have some questions like, first of all, how should my services talk to each other? What about flags? How do I configure my services? And with all these requests bouncing around, won't it be harder to debug? How can users and clients access my services if they're all running separately? And what if a service goes down? Is this better than a monolith in any way? Well, first, calm down. Geez. I'll get to it. All right. How do I expose my services to my users, clients, and anything else that wants to consume my APIs. Let me tell you about two patterns that you can use to simplify the interactions between your services: gateways and aggregator or composite services. As the name implies, an API gateway acts like a door to your application, essentially. The gateway decouples your clients from your downstream services by sending API requests to the appropriate services, without the user needing to care where they end up. You can also use a gateway to aggregate calls and configure the optimal APIs for different types of clients or users. You can even do things like throttle requests to prevent overhead, use retry logic when a request fails, and set up perimeter security to block users from accessing some services that you might not want them to. But please note, perimeter security is not the only type of security you should have in your application. Just keep that in mind. In Spring Boot, turns out setting up an API gateway is as simple as adding a single dependency to your application. Now you're able to match routes with APIs, add predicates and filters to your paths, and even throttle your APIs with rate limiting. Excuse me. In addition to setting up a gateway, you can also create services that aggregate calls to other services. This allows you to simplify your calls between services and implement additional logic like retry handling or exception handling. This is really nice for when you want your users to be able to perform complex operations in a single request without worrying about the implementation details of the downstream services. So, for example, Louhi's flow service is a composite service that manages flows. And when a user wants to create a flow, the flow service talks to these other services to create new pipelines, notifications, and triggers so that the user doesn't have to. This allows the flow service to report exceptions also from the other services back to the user and to retry executing pipelines when they fail, for example. But speaking of retrying things when they fail, is it possible to perhaps configure the number of retries that I attempt without redeploying my service? You might be asking, what's a good way to configure my services? After all, the services might have a bunch of configuration applied to them depending on the environment that they live in, right? Things like retries, feature flags, URLs and ports. You might have pub subtopics and timeouts that you want to configure. Do I have to reboot the service every time I want to change something? Turns out, no. Fortunately, Spring Cloud Kubernetes allows us to apply these sorts of changes to our Kubernetes configuration map, which then delegates them to our already deployed services. When we need to use a configured variable in our source code, we just use the @value annotation in Spring, and whatever change we made to its value just gets automatically applied. It's nice. Since GlassPane doesn't use Spring, though, we didn't have this cool configuration management out of the box, so we basically decided to implement the same functionality ourselves. We created a new service called the configuration microservice, and essentially it listens for changes to a protobuf file in the configuration repository, and whenever we make changes to that file, the configuration service detects them, re-emits those changes via pub/sub to all the services that need to listen to those events, and those services can just pick up those configuration changes using a similar annotation we created in Java. All right. Once we have the services running, how do we make sure that we can carry out really complex operations in our application across all these different services that we have? How do we coordinate them? For an example, imagine a user wants to delete a project in Louhi. In response to this request, the project service should delete a project. Simple, right? Well, not quite. Remember that in Louhi, flows are composed of other things like pipelines and flows and triggers that shouldn't fire once a project is deleted. Otherwise, these orphaned flows and triggers might rise from the dead like zombies. Spooky. And what if also maybe environments need to be updated or pipelines need to shut down? And what if in the future, a new service needs to know when a project gets deleted? What if we're maybe collecting metrics about when projects get deleted or something? How can we make all of this happen atomically so that operations don't affect each other in ways that they shouldn't, and everything still happens as you expect, even though the logic is spread so far across your microservices? Furthermore, we need to be able to roll back, remember, if something fails along the way. Thankfully, saga patterns exist, and they are designed to handle exactly these types of complex transactions while ensuring that operations do in fact happen atomically. Let me tell you about two of them: orchestration and choreography. In orchestration, as the name suggests, you essentially have a single coordinator or director service that maintains the state of the system. It tells other services what to do, and if something breaks, it makes sure to handle it. There are downsides to this centralized approach, though. You should consider potential overhead for complex operations because you only have one thing managing all the state. In choreography, on the other hand, services produce events that other services react to. There's no single service coordinating the actions. All services are responsible for handling their own state by subscribing to whatever topics they need to. In Louhi, we use both, in fact. For example, we use a fan-out approach to emit events from the project service when a project gets deleted. Through eventual consistency, other services listen for that event and react accordingly. We also use a fan-in approach when a single service is interested in events from multiple services. The metric service, for example, uses this technique to collect metrics by listening for events from multiple services. Handling transactions in any type of application can be difficult, so just carefully consider them to make sure things work out smoothly and can be rolled back safely. Okay, we covered a few handy saga patterns for coordinating your services, but as your application grows, how do you keep track of requests being sent between your services when you need to debug them, for example? Distributed tracing is a really nifty technique to do this. You may have heard of a tool called Zipkin. It's a protocol, actually. It's a protocol Spring uses to add breadcrumbs to HTTP headers automatically, which allows you to track requests as they bounce from service to service. As an alternative, there are tools like Envoy and Istio, which I'm sure you've heard of around the conference, that they create a service mesh to essentially enhance your HTTP requests between services on any tech stack to provide your application with distributed tracing capabilities out of the box. To implement distributed tracing in Louhi, all we needed to do was add these two dependencies to our project. After this, our microservices began pushing information about requests to Stackdriver, and we can even watch them live as they happen. So back in our GCP console, we're able to see requests bouncing across our services, and simply by clicking on a specific request, you can directly view the logs for the service that generated that request. It makes troubleshooting errors relatively easy. Okay, so I've addressed some of your concerns, hopefully, about how to expose your services with gateways, configure them without redeploying them, coordinate them with saga patterns, but there are still a couple major common concerns that I want to address before I end this presentation and open up for questions. I promise we'll get there. We're almost through. Namely, you might still be wondering, how do services find each other? And when I add a new microservice, how do the others know it even exists? Turns out there's a name for this: service discovery or discoverability. For services to find each other, you typically use something called a service registry. When a new service is created, it registers itself with the service registry to say, hey, I'm a service. Hello. When one service is interested in talking to another service, then it just goes to the service registry and asks it which services are available. And thanks to Spring Cloud and GKE, This is relatively simple. Here's an example of how we use service discovery in Louhi to add a new type of trigger, the pub/sub trigger, to the trigger service. We implemented this new pub/sub trigger. We were able to just drop it in the cluster. Then that new trigger service registers itself with the service registry in GKE. The trigger service picks up that change from the service registry that all the services can talk to. Now, whenever the trigger service, for example, needs to ask what types of triggers are available, it now can interrogate this new service and say, hey, are you a trigger service? And if it responds with the expected request, now the trigger service is aware that the pub/sub trigger exists, and voila, you now have a new trigger without having to redeploy anything. All right, finally, this is a question we get a lot. What if a service goes down, right? What should you do if one of your services fails? Unlike monolithic apps, a major benefit of microservices in having separate binaries is that your application can continue to function, right? Instead of crashing when one piece of it fails. It's really cool. And if you've been paying attention so far in my talk, you may have noticed a pattern, and you may be able to guess what I'm about to show you next. That's right, more patterns. Yay. OK, almost done, I promise. All right, the circuit breaker pattern and self-healing services. The circuit breaker pattern is used to detect failures and allows your application to react to them intelligently. So this is what the flow service in Louhi looked like before we implemented the circuit breaker pattern. In this example, the user wants to start a new flow, which should execute a trigger by talking to the trigger service. But what happens when the trigger service goes down? When faced with an endless loading screen, the user might start clicking the button furiously, saying, create a new trigger, what's happening? Why aren't my triggers being created? Well, currently, there's no way for the user to know something down the line failed and they're stuck. What do you do? Well, let me show you how we can improve the user's experience by implementing a circuit breaker, adding it to the flow service. So when everything is functioning normally, the circuit breaker does nothing, and it just passes the user's request along to the trigger service, and the user's happy. But again, let's say the trigger service goes down for some reason. Now, the user sends a request, the circuit breaker may retry a few times, and then the circuit gets opened when it realizes, hey, I've tried a couple times and nothing happened, we should do something else. There, it reverts back to some other logic or shows the user a useful error like, hey, the trigger service is down, come back later. To see how this might look in code, I'll show you how we implemented the circuit breaker pattern in GlassPane. So the code you see here was actually before the circuit breaker was added. And as you can see in that last line of code there, the service will just throw an error whenever the metric service is down. It's not terrible, don't get me wrong, but we can do better. To improve the user's experience, we created our own @method retry annotation, which acts like a circuit breaker. As you can see, this allows us to configure the number of attempts as well as a fallback method to revert to a different behavior when it fails. So this time when the metric service fails, we actually go to the local memcache and fetch metrics that we've already collected in the past so that we can still show the user some useful information even if the metric service is down, instead of just throwing an exception. And best of all, this annotation lives in the common repository I told you about, so all the services can use it without having to rewrite it or depend on each other. Another useful thing to have is self-healing services. Wouldn't it be great if your services just rebooted automatically when they failed, or maybe reverted to like a previous working version when they went down? Well, it turns out this is actually possible. Kubernetes, for example, is able to monitor the health of your application and find out if it's down. And if it is, Kubernetes will try to spin up a new instance of your service or you can even configure it to revert to some other previous working version. But in order to do this, you need a way for your application to report back its health. And it turns out you can also, you can also do that. So in Louhi, we use Spring Actuators to do this. The actuators, they essentially just add additional endpoints to report the health of your application back to Kubernetes. And if configured correctly, you can even take advantage of other tools like Micrometer to gather statistics about your services, like uptime and your overall application health. We just covered a lot. Using a service registry for service discovery, the circuit breaker pattern when services go down, and reporting the health of your services. But what does all this look like in code? Well, it turns out Spring has these wonderful things called Fane clients that can basically do all of this out of the box with only a few lines of code. The code you see here is how we set up the APIs for the store service, register it with the service registry, implement method retries, and report back to the service's health and status. It's pretty crazy. Oh, Spring uses these sort of naming conventions to make all this happen in the background, in case you're wondering. It's really cool. So last but not least, how could we forget everyone's favorite thing, tests? Hooray! You may be wondering, how do I test and deploy my services safely and securely? There's also ways to do that, and essentially, I'm going to sum it up in one word: automation. I don't have time to go into detail, but use existing CI/CD tools and frameworks such as Cloud Build, for example, to continuously test and deploy your services automatically. If you're willing to upgrade your monolithic app to microservices, you should be willing to use modern testing and deploying infrastructures. Just putting that out. Your life will be easier in the long run if you do. All right, so there's a lot we didn't cover. You should have a separate CI/CD pipeline for each microservice, for example. Have a rollout strategy and have a rollback strategy. Decide on a strategy to migrate your data, and again, beware of the data-driven migration pattern. Again, Martin Fowler is a really good resource for not just this, but also for microservices in general. Set up error reporting, logging, and metrics for your services, and don't forget about security and testing. Finally, use existing tools, as I mentioned, to automate your infrastructure as code or configuration. So, what can you take away from this presentation? Well, earlier, we talked about some of the pros and cons of monolithic apps versus microservices, and how microservices came to be. I told you why we initially built Louhi and GlassPane as monolithic apps, and why we decided to migrate them to microservices, despite the refactoring costs. Keep in mind, it is a costly process potentially, right? But microservices allowed us to iterate quickly and to focus on the business logic once we'd handled all of that migration. Throughout the presentation, I showed you how to take advantage of some existing patterns, like the Strangler Pattern to slowly break down your monolithic app, Saga patterns to enforce atomic operations, and the circuit breaker pattern to handle when a service goes down. We used examples from Louhi and GlassPane to show you how this can be done using different tech stacks, as well as some anti-patterns to avoid. Ultimately, though, there's no one-size-fits-all approach for this. The perfect application doesn't exist, but hopefully you learned from our experience with Louhi and GlassPane and you took away some useful tips for how to choose a good architecture for your app, and I hope the road ahead is a little clearer now, and I wish you the best of luck on your journey. Special thanks. Thank you. Special thanks to these folks, without whom this presentation wouldn't have been possible. All right, now I think we have a couple minutes, maybe 5 minutes, to open it up for any questions from the audience. Oh, and don't forget the survey app. Tell me if I did a bad job or not. Oh.
So let me start by saying that you have done a good job. Yeah.
Sorry?
let me start by saying that you have done a good job. You have explained it quite nicely.
Thank you.
The question that I have is, of course, everything originated from service-oriented architecture. I am from an old school SOA person, and I can see lots of similarities with SOA. For example, you have an aggregator or whatever, and if the aggregator goes down, you have essentially lost all the services behind it. Yeah, so there are pros and cons to every approach. And whenever you want to decouple, having a pub sub in between or having a queuing system, for example, to ensure that when the circuit breaker breaks, it essentially starts flowing into a queue and then things get processed later on. But is there anything within the API gateway pattern, for example, where you don't use an aggregator, but the gateway itself does all this for you? Is there a functionality like that within Google Cloud?
So you can do, essentially that would be, I think what you're describing would essentially be orchestration, where you have some centralized place that's responsible for handling all the API requests that are being sent throughout your application. Is that what you mean? So the orchestration pattern is pretty useful. I mean, it does have some disadvantages, like if you need to carry out really complex operations, it might take it a while. There might be some overhead because it's just one thing. And it has the nice caveat that if you're not using coordination to emit events across your services, then you don't have to worry about where are all my events going when they're bouncing across all my services. You don't have to worry about that as much. So yeah, orchestration can be nice for that. Any other questions? Oh, looks like we've got one back there. Or either one, whatever. Sorry. Be sure to get to you after.
Hello. Sorry.
Hi.
Regarding testing, so when we moved from a monolith to microservices, we changed the way of testing in general. It's not just about the business logic, it's also about the communication between services. What kind of... Yeah, because what kind of approaches, what kind of pattern did you use when you had to test the whole picture, the entire picture?
Yeah, that's a really good question. So there are several different types of tests that are really useful to write. There are things called unit tests, which are just testing the business logic, and maybe if you're familiar with other types of tests like end-to-end testing, as well as integration tests and those kind of things. So if you're creating this microservices architecture, you do still want to have those types of tests where you have integration tests that actually test the interaction between two services, for example, or end-to-end tests where you say, if a user requests this, and this whole series of events happens through the microservices, that you ensure that everything along the way happens as you expect, atomically, like all the things that I mentioned in the presentation. As for patterns to use this, there are existing tools that will help you test across your microservices architecture. But essentially, you can think about it as testing any other application that might need to send and receive API requests. So like HTTP requests, or if you're using like gRPC or something, you can test those endpoints the same way you would with any other application.
Thank you. Yeah.
Does that answer your question?
Yeah, I was thinking more about sometimes some people can make the mistake to not test the entire picture, and you can end up in having that timeout cascade.
Right.
You don't know what is happening, and you never know until you get into production. No?
Yeah. That's one thing that something like continuous testing will handle, right? Because especially if you have multiple staging environments, you want to make sure that when you're deploying changes or feature flags or whatever configurations, you deploy them to separate staging environments. Like you still want to have QA versions of your binaries or dev versions, for example, that you can deploy across, so that you don't end up just deploying straight to prod and then waiting to see if everything fails, right? So yeah, tests are still very important. Thank you. It's a good question. All right, maybe we have time for one more, or, oh, looks like we gotta wrap it up. Maybe a quick one? Is it quick?
Yeah.
Okay.
So
Go ahead.
when we decided to break the repo, how would the follow-up on the reporting and other things would work? Do we go back to individual services once again to bring all the data together? So when we have to report on those data sets.
Oh, you mean doing like collecting metrics and reporting errors and those kind of things? Well, so that's you can use something like the fan-in approach that I mentioned earlier as part of one of those Saga patterns, like the coordination pattern, where essentially, like we had the same exact service in Louhi where we needed to collect metrics and report errors from multiple services. So essentially, we'd listen to events from a bunch of different services and display them all in one UI. So you can do that using the it's called the fan-in approach of the coordination pattern.
Thank you.
Happy to help.